the conclusion and that's overall the concept is right here. Why STP exists? The first principle is thinking. So the STP is because of we have to prevent the broadcast storm. Okay, if the STP is not there, so there is a highly chances of broadcast storm will going to be created, and that will overload the network, and on at any point of the interface, on any interface there is a collision is going to be happen. The broadcast is going to be overwhelmed itself, and the MAC address is going to be feed itself again and again, and going to be rewrite the MAC addresses again and again, and it's going to be busy the chip, that all sensors, all what we can say like the whole processor of chip consumption is going to be waste to it, or MAC address table is going to be use it itself again and again. So yeah, it's going to be bother the whole network. Okay, so to prevent this all thing, we do use the STP in a better way, like in a better way to figure out the whole thing, how actually the logical stuff, like this is the physical existence of this interface, this topology that we can see. But here's the thing, if I will going to be create a different unique logical link which is going to be make invisible in logical, like in virtual ways, like for the VLAN 10 maybe this interface will not going to be count in that, for VLAN 20 this interface is not going to be count in that, right? So there's a chances to be make whatever is looking apart from that. Okay, there is a several possible logical links or logical interfaces which is virtually going to be work, but if physically it's look like that, I will going to be do that all possible understanding to figure out that all. Right here the assistant is going to be help out this all the way. Okay, so here in your topology the multiple switches, yes we have multiple switches, redundant links, that's why we are doing this all. The redundant links are there, loop are possible, definitely there's a loop are possible, so we are going to implement the STP to prevent these loops. Okay, as you can see there is nothing about indicators, like link lights are not there, so definitely you can't guess that where is the root port or designated port. So these all you can't guess that, right? So I did it intentionally to understand the whole thing better, so that we are going to be further out further. Okay, now without STP, so the broadcast frame loops forever, network crash, yeah it's going to be happening if STP is not working in this topology. Okay, with STP one switch became root bridge, definitely the one switch going to be elected by the all switches on the basis of the lowest bridge ID, or we can say something that it's totally based on the bridge ID. In bridge ID there's two identities, that's a priority number and the MAC address. So we have to compare if in case the priority number is going to be tied somewhere, so in that scenario we have to compare with the MAC address as network. Okay, with the switches in between switches. Okay, so yeah, this is the thing that we do for electing. This is the thing that switches do in order of election. We have to just understand this thing. Okay, some links forward, some block. Yeah, after election some interface is going to be a link going to be work as a forwarding state. Okay, let me tell you, there's 4 states. Okay, apart from disable state that we call the interface down. So if I will count that would be 5, but mainly there's 4. That's the blocking state, listening state, learning state, and forwarding state. So all designated ports, the root port or the blocking port, or listening and learning. Okay, so if I will talk about listening and learning, so all end devices like these all PCs, the end of that is if I will plug into it. Okay, if I will if I will remove this, okay, again I will connect it, so it will going to take out 30 seconds. Okay, thereafter it will from orange to green, it will the link light will going to be orange for 30 seconds. After that will make itself in green. Okay, so it means that the 30 second that take for the learning and listening, the learning and listening part take 30 seconds, because of the listening part take 15 second and learning part take 15 second. It means that overall that would take the 30 second for this thing. Okay, yeah, this is all about this. So forwarding and blocking. About forwarding state, so in forwarding states there's a in this order I would say there is a three thing happens. Okay, it's going to be do all possible three things which are relevant with what it's all are relevant with the like regular traffic. So the forwarding state will going to be forward the all regular traffic. Okay, that's always let's do the BPDU traffic or BPDU messages, that will also going to be passed through by forwarding state. And the MAC address, forwarding state also learn the MAC addresses. It mean that the forwarding state going to be give this all the green chit. Okay, the green chit is going to be give it to all like the all indicators, or that we call say we can say this all identities. Okay, now what about the blocking state? In blocking state, the BPDU messages only receive. Okay, if there is a only here, if there is a blocking state, okay, on interface F03, assume that there is a blocking state. Okay, so the BPDU message only receive, that will not going to be sent somewhere. Okay, and what about that's like regular traffic, that will also going to be bound over here, that will also going to be end up over here. Okay, and the third thing, the MAC addresses. So in a blocking state, the MAC address is not going to be learned by these ports. Like in blocking states, if any port is in a blocking state, that will not going to be learn the MAC addresses. There is a two only state who do learn the MAC addresses, that is the learning state and the forwarding state. There's two major states are which work in between these all. Okay, now network stays loop free. What does mean of the loop free? It means that the whole logical things which is working inside there, so somewhere it's going to be block any interface, and somewhere it's going to be just act as a designated port or in this topology, and somewhere it's work as a root port. So it means that this whole thing is going to be logically divided. You have to work, you have to stop the traffic, you have to go, you have to just wait for that for the 30 second. These all are the things are going to be decide to it. Okay, and then after it will going to be the make decision on these all. So the collision, it will not going to be happen by this all security stuff, like if somewhere like authentication on somewhere on your gate, and just try to know if it will go, so it can make a collision on somewhere, so definitely it will going to stop that person, or this kind of scenario that you can assume like this. So it will going to help you to relate with this all the way. Okay, so it means the whole thing is going to be logically decided, or they are going to be work logically to without plugging out any interface, that will going to be logically down virtually. Okay, not physically, but logically it's going to be down to prevent the collision, to prevent the broadcast storm. Okay, so this is all about this mean the loop free. Yeah. Okay, so what changes when you use the VLANs? Yeah, when we use the VLANs, what are the possible things that we can do? We can overcome the load of the interfaces, or that we can say we can separately divide the traffic, we can balance the load. Okay, we can balance the load by separating the VLANs on different for the different STP. Okay, for if I will creating the one bridge. Okay, if it's going to be create the one bridge for the primary, primarily I'm going to designate a kind of root bridge for the VLAN 10. So that will going to be primary and secondary, that we do create, or it's going to be assign or elect. Okay, so that is the thing that we are going to be do for the VLAN 1, switch 1 and switch 2. So what we are going to be doing that the switch 1 will going to be create the root bridge, the primary root bridge for the VLAN 10, and the secondary root bridge for the VLAN 20. Remember that, I'm telling again. Switch 1 is going to do the secondary as going to be act as a primary root bridge for the VLAN 10 and secondary root as a secondary root bridge for the VLAN 20. In the same way but differently, the switch 2 is going to be act as a primary root bridge for the VLAN 20 and secondary root bridge for the VLAN 10. It's opposite of this. Okay, so that we are going to configure in that. So what it say, let's see, VLAN 10 has its own root bridge. Okay, that's the thing I'm talking about. The VLAN 20 has its own root bridge. That is the thing. What is how we load balance traffic? How it's do? It separately divide the traffic. So, or the load of that, like on one single interface the VLAN 10 is going and VLAN 20 is going. So for the different ways we have to just figure out. So I'm going to decide the VLAN 20 for the primary and secondary. Likewise, I'm going to create the logical reason behind this, so that will work. Okay, so what about the bridge ID? This is the heart of the root election. STP choose that root bridge on bridge ID. Okay, so the bridge ID, as I said, that the priority and the MAC address. Okay, so there's a two major thing that's actually work, the priority and MAC address, that will combine and that will make the bridge ID. The rules are given. The lowest priority wins, as we discussed over here. If ties, so we have to go for the lowest MAC address to make comparison to elect the root bridge. Default priority 32768. This is the default priority. That's number. It should be work and like everywhere. Okay. So it means that something that we are going to be do that will work all the way. Okay, now we can continue. Okay, okay, that's why the switch 3 became the root bridge by default, the lowest MAC. Okay, we don't know who have the lowest MAC. We can't decide who have the lowest MAC. We have to go like in a switch 3. This is the reference, whatever is given over here. Let me check. Is all is going good. Okay, yeah, so yeah, this all are the which you can see right here, which all are like, this is the reference only, and whatever we are going to be do, let me check it over here. I will go in global configuration mode. Now I'm in a global configuration mode. What I have to do is I have to check, right? So do so spanning. Okay, let's try to fetch or try to check with the domain server. I can go with it and check the switch one. What was that? What was happening over there? That was what we call this time delay. When we type any wrong command, so that will try to check to the server, is it something which is out of the command, so they try to know something about it to connect the domain server. Okay, if it's not a genuine or real command. Okay, so do so, not do so, we have to spanning tree, right? Yeah, spanning hyphen tree, right? Yeah, okay, so as you can see the bridge ID, which is by default, as you can see right here, +1, because of this is a VLAN 1 is there into it, inside there, like this is what we call the VLAN 1. Because of that is add to it the by default this value, and that will make the 32769. Because of that you can see this is in a this way, like as it is given over here. Okay, so yeah, it's by default is talking about the by default. So yeah, it is here. Here you can see. Yeah, this is all about that. Okay. Yeah, but further, what we see, our design logic very important. We want the VLAN 10 traffic to prefer the switch 1. Okay, we want. It means that we are going to design the logic. Okay, so VLAN 20 traffic to prefer switch 2. Over here, the switch 2, it's not visible because of this tag is given over here, so that's why this is let me clear to you. Okay, so switch 1, switch 2, switch 3 and switch 4, remember that. Okay, so manually control priorities. Yeah, we are going to be manually do configuration, or we are want to create the logic manually. We are going to be do whatever that will be, that's manually, and this is a logic that we are creating. So this is all about what root primary and root secondary, that I have to decide. Okay, so this is also thing that we have to make sure what are the thing into it and how we can do. Okay, the Cisco automatically primary root, in primary root what's it's do really. So the Cisco automatically set priority to 24,576 or lower. Okay, and let me tell you, there's a value that we call 4096. Okay, that will going to be low. Okay, like it's telling the lower, so the Cisco automatically set the priority to over here like this. Okay, or lower. So how much it's going to be lower, how much it's going to be make it lower? So firstly it's going to overcome the 496. Okay, 4096. This is a kind of multiple to it, or we have to just go above, or we have to go above to it. So we have to add 4096, and if I want to make it lower, so I will go down with number, like I have to just subtract with the 4096. This is the way. If I want lower than that, so I have to do the same thing. We have to play with that number 4096. Okay, guarantees this switch became root. Yeah, that is the thing that we have to make. By default we see this. If I have to make this thing, like if I have a prayer, if I want to make this thing in real by manually, so I have to do, if it's not working, so we have to go with the lower than that. Okay, guarantees this switch became root. Yeah, definitely if I will do this configuration, it would be okay. So root secondary, set priority to 28,672. Okay, became backup root. This is for what? This is a root bridge secondary, so this is a backup root. Remember that the secondary root bridge that we call the backup. These are the keywords. If someone is talking about the backup, so you have to consider whatever I'm just talking. I'm also a learner, you know, so if I will see like this type of thing like the backup root, so I have to just relate this thing to, like, in a general term. If someone will ask about what is a backup root bridge, which one is a backup root bridge, so I have to just think like, oh, secondary would be a backup. Yeah, so that is, this is the surfer. Then okay, then manual priority. Yeah, that is because if the first thing will going to be happen, or whatever the situation in that, so how we can, it's a safer. Why it's safer? I really don't know what is the mean of that, but what we can say, okay, it means try to say कि whatever we do in real manually, this is the safer than manual priority value. Okay, if we will going to set any number which is I want to set as it is large. Okay, so I will set the my maximum, or the all possible maximum ways to set. So this is the, I think the maximum that we call the maximum, or let me know about this what it is. be curious about anything whatever we see. Okay, yeah. Okay, okay, 32 I think is the maximum if I'm not wrong, right here in this table where it is. It's gone. Yeah, where's that? Like, yeah, default. We have to go with the default, right? Where's that right now? Okay, so okay, this is the as you can see, as I told, 4096. If I will add in this value, if I will add the 4096, so that will become this value, right? So this is the thing that is talking about all over this thing. That's I was just roaming around this all, and this is the thing that I want to do. Okay, but this value, something extra is talking about something extra or something what we call like to make understanding better. Okay, be curious. Okay, if I will feel like I'm stuck somewhere or something is new for me or any reason behind anything, go and search. Don't be lazy about this all. Okay, be curious, attentive. This is all the, no one like nothing going to be happen miracle. Okay, so whatever you will do, learn, this is all it that will going to be just all around you. Okay, so what is next? The design plan, visual thinking, VLAN 10, VLAN 20, the root phrase, switch 1, switch 2, backup. Okay, for this VLAN 10 backup would be switch 2. Okay, for this it would be okay, switch 3 became the normal switch automatically. Okay, let's see, switch 3 became the normal switch automatically. Yeah, that we call like that we usually do. So let's see what we can do with it.